Hi, I'm Mark, and I will demonstrate how to set up the MPVS Duo and LabChart for PV recordings in large animals using the conductance method. Connect all the hardware as per the video entitled MPVS Duo Hardware Setup for the conductance method. Make sure you have installed LabChart and the PV Loop 2.6 module. Switch on the MPVS Duo by pressing the on button on the keypad. Start LabChart. Close the Welcome Center, click on Setup and then Channel Settings. Reduce the number of channels to 3 and name Channel 1 Pressure, Channel 2 Magnitude/Volume, Channel 3 Phase. Click on OK. Once the MPVS Duo has initialized and with a catheter connected, press 1 to start a new PV loop protocol and then press 2 to select conductance. You will now be prompted to soak the catheter for 30 minutes. If the catheter has already been soaking for 30 minutes, you can then press forward arrow to go to the calibration screen. In LabChart, select the PV loop menu and select Workflow. If this is grayed out, check that the Enable PV Loop Workflow checkbox is checked under the Workflow Mode item in the PV Loop menu. This will open the workflow window on the left. First select the workflow. In this case, it's MPVS Duo Large Animal Conductance. Next, select the channels in LabChart designated for pressure, magnitude, and phase. These should correspond to the channels connected to the MPVS Duo unit. Once all selected, a green checkmark will appear next to the Setup PV Loop item in the workflow. Now go to the next item in the workflow list, namely Duo Channel Calibration. Select the type of catheter you'll be using. The list allows for series of ventricaths and manual. Manual is used if you want to enter values from scratch. In this example, I'll use the Ventricath 2 catheter. It is suggested to use actual voltage values from the MPVS Duo, as there could be variation between systems. To do this, start LabChart. On the Duo, press 1 to go to the low voltages screen. Next, press 0 to output this to LabChart. Record for a couple of seconds and then press left arrow on the Duo to go back to the calibration screen. Next, press 2 to go to the high voltages screen. Again, press 0 to output this to LabChart, and then the left arrow again to go back to the calibration screen. Stop the recording in LabChart. Now for the pressure channel, select the region of LabChart just before and just after where you can see the data jumped when it received the high calibration data. Add these to the pressure calibration boxes, one for 0 mm of mercury and one for 100 mm of mercury, as demonstrated here. Repeat this for the remaining 2 channels. Do not forget to check the Apply Calibration checkbox for each. All 3 channels are now calibrated. Start LabChart. Then on the Duo, press the forward arrow to move to the Balance Pressure screen. Next, press 1 to balance the pressure sensor in the PV catheter. Press 1 to zero the pressure. The current reading on the Duo should drop to 0 as it does in LabChart. Stop LabChart. Now press the back arrow on the Duo to go back to the balance pressure sensor screen. Next, press the forward arrow to move to the experiment screen, where you can also use phase for positioning. Introduce the catheter into the ventricle. For large animal catheters, make sure you select the segment with a size suitable for the animal's ventricle. To do this, press 1 and then the segment number and OK to select. Please see the manual for more information on the segments and their lengths. Segment length can be changed while the catheter is in the ventricle. A low-pass filter can also be switched on or off in the screen by pressing 5. Back in LabChart, move to the row calibration section of the workflow. Enter the row value. Either measured or default values can be used depending on the animal model. Details can be found in the manual or publications. Also select the segment you are using on this catheter. I will use segment 1 and then apply the row calibration. Next, in LabChart, move to the sampling section of the workflow. click on Start Sampling. Once the catheter position is optimal, with phase being within the specified ranges as shown in the manual, and volumes are plausible, the experiment protocol can be followed to record baseline, saline bolus for parallel conductance, and the occlusion data. Once the experiment has been completed, stop recording and check the box for sampling complete in the sampling section of the PV workflow. Now the parallel conductance can be calculated using the saline calibration section of the PV loop workflow. Also, alpha calibration can be performed if you have an independent measurement of cardiac output or stroke volume. Finally, the data can be analyzed using the analysis section. Adjust the detector settings and analyze your baseline and occlusion data.